here to talk about recent paper. So show of hands, who's heard of Tornado Cash? Keep your hands up if you have also heard of privacy pools. And keep your hands up if you've read the paper. It's like 5 of you. All right, great, because today we're going to give the TLDR of the paper. Working on this paper was pretty fun. This was my first academic paper ever. Vitalik basically wrote half of the paper in the first week, which was shocking to the Swiss blockchain bros that we wrote it with. They thought he was just going to be some sort of figurehead, and so they're very surprised. They didn't understand Vitalik. I came up with some terminology, made some diagrams. They were kind enough to include me as an author. So what is privacy pools? It's a new privacy protocol. It's a fork of a UTXO-based privacy protocol. It allows users to publish a zero-knowledge proof demonstrating that their funds do not originate from known unlawful sources, or that they originate from lawful sources. Either way works, you'll see. TLDR, prove you aren't North Korea without revealing who you are. The brief timeline, on August 8th, Tornado Cash was sanctioned. August 30th, Vitalik describes privacy pools in an interview with Brian Armstrong. He explains that there's a way to use zero-knowledge proofs to prove that you're not some subset of the deposits. February 3rd, there's a St. Louis Federal Reserve report on Tornado Cash, which we'll talk about more. March, we demoed the privacy pools version 1 at ETH Denver last year, and then we published the paper in September of last year as well. And next week we'll launch all this stuff, hopefully. Oh, I got to do both my laptop and the. Here's the timeline slide. So why privacy pools? There's a problem. The initial problem is that public blockchains are transparent. We want to avoid revealing balance and transaction history with every payment. We're jealous of Zcash, so we wanted something. We contributed to Tornado Cash. You know, when I say we, I mean like Malik Dow helped pay for the grants for initial setup, and then audits and so forth. It went way better than anybody expected it to go. About 3.6 million ETH went through it. You do the math. The problem was that North Korea started using it as well. And the smart contract addresses all got sanctioned by the US government, so none of us are allowed to use it. Authorized US employees, however. Have fun. Legitimate users had limited options to dissociate from the criminal activity. This is sort of the key issue. And there was a compliance tool that the devs built themselves and allowed users to create a proof of funds origin, so which specific deposit your withdrawal came from, essentially doxing yourself. But it was only for that specific deposit, so it's not something you could publish publicly. It required basically you to reveal this to some centralized authority who would then figure out, by process of elimination, who has not done that. Solution to this problem is privacy pools, where you can publish public proofs that selectively dissociate from illicit funds. I'm going to talk about this Federal Reserve report on Tornado Cash. So this was last year, February 2023, and written by Dr. Fabian Schaar and Matthias Nadler. If those names are familiar, it's because it's the authors of the current paper that we wrote privacy pools about. They explored the trade-off between regulation and privacy, and they essentially suggested to regulators that if they wanted to regulate privacy, they should mandate the use of the Tornado Cash compliance tool and demand that users basically dox themselves to some sort of financial authority. And that financial authority or institution can, figure out who they are and be able to trace their funds if needed. And they conclude that crypto asset mixers such as Tornado Cash are an integral part of public blockchain infrastructure. Personal nitpick, it's not a mixer if you can prove which money is yours, by the way. This is us in Basel. I'm surprised they let me anywhere. But the smiling bald guy on the right is Dr. Fabian Schaar. The guy on the left is Matthias Nabler. Fabian organized a DLT conference. They're really fun. You should go if you haven't gone yet. We got to hang out with a bunch of bankers and regulators. It's my first one. I will admit I was impressed by the Swiss. They have financial privacy in their cultural DNA. They were fairly receptive to the paper. Oh, and this is like the Tower of Basel. I don't know if you know that. It's like the final boss. So let's talk about how this works. It uses ZK snarks. Everybody here has heard of ZK snarks? Great. I'm not going to give you the TLDR. You can prove things without revealing things. It's great. So users submit 2 proofs in privacy pools. First one is the same as previous privacy protocols. It's the one that you say, hello, my coin is being, one for being able to withdraw your coin. It says, I have a valid and unspent deposit. And the new one is one that says, hello, this deposit is part of the specific association set. My coin is one of these coins. When we say coin, it's like the ID of the deposit. When you get the deposit, you get a coin. It's just the terminology. And so this is 2 different Merkle trees that are there. It shows that you don't actually need to have the specific subset of the first Merkle tree. You can just have a separate Merkle tree because the thing that you're proving is that you own the money. And so if you submit the proof wrong that you're part of some set, doesn't really matter to anybody except you. Association sets. So this is a word I made up because inclusion lists was taken by block builders and proposers, and so we had to come up with something else. Association sets and privacy pools could be the full subset of previously made deposits, a set consisting of only the user's deposit, or anything in between. The user specifies the set by providing a Merkle root of the set as a public input to their transaction. So this is an example of how this will, could work. Let's say there's 5 deposits into a privacy pool, Alice, Carr, Bob, etc. If the first 4 fine, upstanding citizens decide that they don't like Eve because her money came from crime or something, they can all decide to exclude Eve in their withdrawals by proving that they're in the association set of everybody except Eve. Eve cannot do this. Eve cannot make this proof because Eve is not part of the set of people that is not Eve. And so despite that Eve provides no information, we can figure out which deposit she is by process of elimination. I just want to pause for a second here to recognize that nothing else on the planet allows you to do this. Like, I get excited when tech actually unlocks new capabilities. You can't go to your bank and then withdraw your money out of your bank and then prove to the entire world that you are not associated with the criminals that use the bank. You can't do that. You can't put your money in Coinbase and then withdraw it and be like, prove that you are not, some criminals that deposited in Coinbase. It doesn't work. But with privacy pools, you can. And so on that one axis, it's the best thing on the planet. It doesn't do everything else that banks and exchanges can do, but of course. So association set construction, you can build up association sets, by thinking of it in terms of inclusion or exclusion. You might think, okay, here are the specific deposits that came from some DeFi hack, some criminal activity, suspicious. And so then you would say, we're going to exclude those. Or you could say, here are all the folks that seem legit, and we create an inclusion list out of those. But functionally, it's the same thing. At the end of the day, you're proving against some set. I'm a member of the set. So in practice, users will not be manually picking and choosing the deposits to include in their association set. When we launched the demo at ETH Denver, it actually did work like that. It was pretty funny. You had this UI, and it showed all the deposits, and you could like point and click and be like, I'm not this guy, I'm not this guy, I'm not this guy. All right, withdraw. And there was actually, somebody dusted essentially our testnet privacy pools by withdrawing from the Goerli, which was on Optimism Goerli. So they withdrew from the Tornado Cash on Goerli, which was sanctioned for whatever reason. And they withdrew from the sanctioned Goerli. They used the bridge, the Optimism bridge, to take it to the Optimism Goerli testnet, and then they deposited it into our privacy pools demo. And so I got to send a tweet that was like, hello, everybody. Please exclude deposits 63 and 80 from, just for fun, just to demonstrate how it works. But yeah, so users will subscribe to intermediaries called ASPs. So you want to automate this process. You want some organization that can do the analytics to trace back the funds and make sure that they're okay to be included in the association set. You're not going to do this for all the other users of the system. So ASPs could maintain sets with certain properties, not a known terrorist or DeFi hacker, or wallet seems legit, the funds came from KYC'd exchanges, right? And so they'll probably also use inclusion delays to make their determinations. They're not going to allow everything on the list immediately. And some other notes on this is that the Merkle root of the association set should be published on-chain, remove some opportunities for malicious activities by the ASP, also provides a essentially timestamping service. So you can be like, look, I proved against the latest association set, therefore my withdrawal is legit. And you also want the ability to download the whole association set so you can locally create the proof of which set your transaction belongs to. Because if you didn't do that, you're like, hello, can I download just these specific, this path? You're basically revealing which transaction you are. So okay. So the original Tornado Cash was a fixed denomination system, 1, 10, 100 ETH, in and out. Put in one, take out one. There's another thing called Tornado Nova, which was a UTXO-based privacy protocol, and that supported arbitrary denominations. And so you could deposit 10, withdraw 1, and it gives you change, a UTXO that says this is 9, right? Now, you have a challenge here where that 9 that you got as change is like technically also a deposit. So how do you prove that this was, came from some deposit that was on the association set? If you can't do that, you have to like resubmit it for verification, and that's kind of cumbersome and annoying. So there's these things called recursive snarks, which I won't explain, but the way it works is you can essentially prove which of these, you essentially create a snark where the 9 coins, for example, also has this proof that it came from the 10 coins and that was on the association set when it happened. And then you can continue to pass along this proof. And then at the end, when you withdraw it, the 4 coins on address 4, you'll be able to say, hey, look, this came from these coins, which came from those coins, which came from those coins, which came from something that was on the association set. And you can prove all this, and then whoever's verifying this gets this bundle, and they unwind the bundle and proofs, and they verify it all. And so there's some special cases for this. Reproofing, which is you withdraw your funds from privacy pools, you want to spend it somewhere, the merchant says, I don't like your association set that you were with, there's some sketchy people in there, I would like you to be associated with other people. And you say, okay, fine. If you still have the secret information that you get when you made the deposit, you can generate a new proof against any association set whenever you want. Another use case for this is like, if there is some crime and there was, somebody gets removed from the association set, and you want the people who already withdrew to help isolate that person, those funds, they can voluntarily provide more a proof against the new association set that excludes that person. So law enforcement might be like, hey, I'll give you like $5 if you can send me this additional proof. Help us find this guy. Special case number 2 is bilateral direct proofs. And so banks might still, for example, say, it's great that you provided proof that you weren't a terrorist. We actually want to know where the money came from. And so you could still create a proof of against the association set of just yourself. You wouldn't want that to be public, because if it is, well, you just lost all the privacy that you got. Sequential proofs, special case number 3. So we also discuss in the paper, UTXO privacy system that has internal sends in addition to just arbitrary denominations. That is actually how privacy pools is built, but we're not doing anything with the internal sends because applying the compliance to it is tricky, which I'll explain shortly. This internal sends adds this problem of inclusion delays, where let's say you deposit into the protocol, you want to spend your money, your deposit hasn't been added to the association set, but you really want to spend your money now. Can you do that in such a way that the person who gets it, they'll eventually still be able to prove that you were on the association set when you eventually get added. And so you can do this if you can see in the diagram, like Alice is, has deposited and is trying to send some money to Bob, and then Alice's deposit is not yet in the association set. And so what Alice can do is give Bob the Merkle branch of her specific deposit and the secret that she used to generate, the proof. And so when she does that, Bob actually has full information about Alice's deposit. And so Bob can later, when Alice's deposit gets added to the association set, generate the proof himself because he has the data to do so. And the idea is that, once Alice's deposit is on the association set, you don't need to continue to pass along this branch in secret, because not only would Alice need to give this information to Bob, Bob would then also need to give this information about Alice's deposit to Carl, because he wants to send the money to Carl, but there's not on the association set yet. And so you can continue to pass it forward until you can prove that the original person is on the association set, and then it's fine. That was the theory of this. Yeah, and so this also works using recursive snarks, where you generate these proofs of proofs and then unwind it all. You continue to pass along with the transaction. And so this is like the explanation is that you can just give the Merkle branch to the next guy. They have the data. They can then generate the proof later if they need to. And not only can they generate the proof of the original, they can generate, if they have all the branches for all the payments that lead to their current balance, they can say, here's the proof that the original was on the association set, and here's proof that this is the money that went to this guy, that then resulted in my UTXO, my balance. And there's a slightly different problem that is also made complicated by the internal sends part of this, and that is what happens if you want to remove somebody from an association set. This is perfectly simple in the fixed denomination or arbitrary denomination versions of this. You just, at the time that you withdraw, you prove against whatever the latest association set is. Doesn't matter if somebody gets removed. However, if you have the internal sends, it becomes a little tricky, because at that point, here's an example of why you might want to remove somebody. You let somebody into the association set, and then they send all their money to Hamas. well, now I don't want to associate with this deposit anymore. I mean, maybe some of you do, but it is Columbia. But personally, I would prefer not to, and so I think most people would prefer not to, and so we'd remove that deposit from the association set. But the problem is, if I'm downstream of funds that have been, I'm getting these proof. I'm getting a proof about an association set at a specific point in time, right? And so Alice, when they, deposit their funds, they get added to the association set. At that point, they have the proof of that specific association set. They send the money to Bob internally. They say, hey, look, I was on this association set at this time. And then Bob can just say, hey, look, the money I got was from a valid association set at the time. But if you remove somebody, now everybody downstream of it, through internal sends can no longer prove that their money didn't come from this person who was removed, because it's a different association set. They don't know which of the people in the association set they got the funds from. And so to solve this problem, you can do the same thing as before, where you send the branch that is essentially the source of funds data that says exactly who you got the money from, and then later, if somebody gets removed from the association set, you can just generate all the proofs that you need to at the time. So I'll conclude this by announcing Oxbow. So my GIF got ruined. This is supposed to be the formation of an Oxbow lake. So it happens like this. The first step, there's a river, and then the river attaches to itself, and then there's some isolated liquidity that gets sectioned off here. And so, yeah, Oxbow is a new company. Check it out. Follow us on Twitter. It's supposed to be the first ASP for privacy pools. We're going to be doing all the monitoring and compliance to build up the association set of all the deposits. Thanks.
Thank you, and I think we have time for one question.
Yeah, well, he's going to give you a mic in a sec.
Okay, so you can have multiple association sets.
Yeah.
So I wouldn't be surprised that the North Koreans view us as wrongdoers. They can have their own association set, right?
That's right.
So you're helping them too. How is the government going to view that?
Next question.
I had I think it's a variation on that question, which I wanted to hear more about how you see the relationship between on-chain trust and on-chain guarantees and off-chain anchors. Because you sometimes used language that was a little bit of that slippery passive. Like, what was the thing? You commit a crime and somebody gets removed from the association set. Like, what's the off-chain entity you see doing the removal? What if North Korea holds you up at gunpoint and steals your password and then acts as you? Like, what's your view on the relationship between on-chain trust and off-chain trust, which could ultimately come from a good old-fashioned rule of law, which I'm probably I'm a fan of, but
yeah. Many such cases, people like law. Yeah. So, what are you doing here? This guy built this thing. Give it up for Ekrem. Yeah, Chainway, the Turkish guys. Great firm. So to answer your question, off-chain trust, on-chain trust, the TradFi answer to this is KYC everybody, right? But that's not good enough for the reason that you said, because there's money mules, right? North Korea says, hey, give me your passport, you're going to start laundering my money, or steals identities from people in order to do the same thing. And so, like, if you come in and you KYC and you pass KYC, and yet we trace the money and you have like $100 million from a DeFi protocol really suddenly, we're gonna be like, no, was this a legitimate transaction? Do you actually have $100 million? Did you just rob this protocol? That kind of thing. And so Oxbow will manage, its association set based on the decisions that we make, that we believe that most people that are our customers would prefer in order to be associated with. And that comes from, the ultimate goal is to have withdrawals from the system be able to be included in the broader crypto ecosystem, right? We don't want a situation where you withdraw from this and then get flagged by every exchange. You want a situation where the exchange looks at this and says, you proved actually that you were part of the Oxbow whitelist, association at the time that you withdrew, and you proved against the latest one, and that's good enough for us, to prove that you're not, a terrorist or something like that. And so some of this stuff is obvious, right? So like when Axie Infinity got hacked, you see all of the money go in, right? And so you can very easily say, not this money. But at the end of the day, the decision is internal to Oxbow for our association set, and other people can have their own. And so, you don't want a situation where like somebody takes their girlfriend or like ex-girlfriend off the association set because they're like mad at her or something, right? And so, it would be good to have some multi-party governance eventually or oversight over the system, but you don't want to make everything public because that might reveal information that you have or make it easier to game. I hope I answered the question.
Awesome. Let's thank our speaker again. And we're going to be back here at 11:20.